Alright, in this video we're going to go ahead and be serving up a healthy dose of cotangent graphing here. And what I want to do is that I want to, real quick, this is what our tangent graph looked like. Okay. Now, cotangent, you got to remember, is going to be the reciprocal of tangent. And so cotangent is going to be 1 over tangent by definition. Okay. So what I want to do is that I'm going to graph out cotangent just using the values that we have on our chart that we went ahead and filled out. And then let's take a look at the similarities and dissimilarities between the two. Okay, so here is cotangent almost over a couple periods because I just wanted to get the central part correct so we can use it. But one of the interesting things is, again, since they are reciprocals, okay, notice that everywhere that tangent has an x-intercept, okay, is going to go ahead and be an asymptote for cotangent. And that means is that if I'm going to take the reciprocal of 0, that's going to be undefined because that would be 1 over 0. And likewise, everywhere that tangent had an asymptote, which is going to be here and here and here, is going to be some x-intercepts for cotangent. Okay, and so that's kind of where the graph comes from. And looking at the chart, you can see the similarities and whatnot. And when I say the chart, the thing that we went ahead and filled out when we were learning about all the trigonometric functions and their values as we went one turn around the unit circle. Okay, so let's fill in the bottom so we can be on our way on kind of getting our hands dirty with graphing this guy. And so our physique is in the standard position is going to be regular. Okay, period, the distance between the asymptotes is going to be pi, and that's where it repeats itself, so that's going to be the same. The phase shift is still going to be none, and vertical shift is still going to be none for the time being. X-intercepts, so if we take a look at the first positive x-intercept, which is going to be pi over 2, we write them as pi over 2 plus the distance to the next x-intercept, which is just going to be pi. Okay, that's when it's going to repeat itself because we haven't shifted it or moved it around any. Pi n, where n is an integer, comma 0. All right. The y-intercept of this guy, we can see that there is an asymptote right here. So that means is that we're not going to get a y-intercept in the standard position. None. Okay. And what we're going to go ahead and do is we look at the domain, and the domain is the first positive or 0 x-intercept. I'm sorry, not the first positive x-intercept or anything like that. It's going to be the first positive or 0 asymptote, and this one starts at 0, so we don't need to worry about that guy. So it's going to start with the next one where it's just going to be pi n, all real numbers except x equals pi n, where n is an integer. And then finally, our range is going to be the same. It's going to be going from a negative infinity to a positive infinity. And so that gives us any of the values that we can kick out with those. All right. So, and before we start graphing, I want you to kind of home in on this piece right here, because this is where we're going to start our graphs, okay, from 0 to pi. And as we can see in this slide here, this is where we're going to start. And we can start at 0 and just move the period on over. In the standard position, it's going to be pi, and that might change based on what we do in the next examples here. And that's different than tangent, where we had to split it over in each direction, if you will, going from the y-axis. All right, so that's what we're up against, and so let's move on to our first graphing example of cotangent.